So here we go. Number 1, 25% of you got it right. So a circle is inscribed in an equilateral triangle. An equilateral triangle, all 3 sides are the same. Here's what you know. This is the hint. Equilateral. Everything is 60, 60, 60. If this is a special triangle, this is where all our trig comes from. Our trig comes from an equilateral and it comes from a square. So the equilateral, you got to remember this. If you drop from this vertex right here and you go straight down, that's going to do 2 things. It's going to make a 90. It's going to cut this angle in half. You got a 30, a 30. And it cuts this in half right here. So the sides, each side is 2 square roots of 3, 2 square roots of 3. It's going to cut this in half into 1 square root of 3, 1 square root of 3. And it does that from every vertex. If I go from this vertex to the other side, even though it's hard to imagine because it's rotated, it's going to do the same thing. It's going to take that to a 30, that to a 30. It's going to go 90 there, and it's going to cut this in half into 1 square root of 3 and 1 square root of 3. And if you do the same thing here, it's going to do the same thing. Now, this is the center of our circle. So if I've got a circle, if I inscribe a circle, that means the circle's on the inside. It touches each of those sides once. Here's what we got. So your math is this. I'm going to look at this triangle right here. This triangle will give me the radius of the circle. So you've got to find the radius of the circle. If I look only at this triangle, that angle right there is a 30. That is a 90. That means this is a 60. And this side right here is 1 square root of 3. And because it's a special right triangle, the 30, 60, 90, you flip it always over the 30 and the 90. So there's another 90 there, there's another 30 here. That whole triangle. And if I know the inside, to go to the outside, you divide by a square root of 3. So this is going to be 1, this is going to be 1, this is going to be 2, this is going to be 2. This piece is the one I am interested in. That right there is the radius of the circle, and it is 1. Your answer is 1. Okay, known in this class, everybody got this one right. So a tangent. Now tangent, when we're talking about circles, tangent is this line right here. It goes on the outside and it touches the circle only once. These two are called chords. They're going to touch the circle twice. And this one's a diameter because it goes through the center. So your answer is B. Everyone's got B. Next one is kind of the exact same question. Question number 3, circle Z is shown. Which of these lines is tangent? That's this line right here. So it is TS, that is A. Okay, number 4, we have never talked about. But if you look at the picture, okay, a median just is the middle. So it cuts in half. So which of these is the median to MNO? And this segment right here, if you look at MO, it was cut in half because this portion right here is congruent to this portion. So if this is 2, that's 2. That means Q is the middle. And a median is the middle. Just cuts in half. So this is the segment that cuts it in half. NQ. How many of you guys got C? How many of you guys got 4 right? Sweet. So we never talked about 4, but kind of with a little intuition you can figure it out on your own. Okay, 5. This is probably like 7th grade stuff. When did you guys do all the scalene, equilateral, right? Isosceles. So that was a long time ago. This guy right here, isosceles. Isosceles has 2 congruent angles. If it's equilateral, this has 3 congruent angles. Do you guys remember what scalene is? Dude, nice. Zane. Shout out Zane Smith. No congruent sides. So one side is like short, one's medium, one's long. They're all different. So if it's no congruent sides, that means no congruent angles. All the angles got to be different. If the angles are all different, the sides will all be different. And the right, everybody knows that, because we've done a ton of right triangle trig SOHCAHTOA. Okay, number 6. You probably did not know. Which is true of all rectangles. So the definition of a rectangle is 4 congruent angles. So 90, 90, 90, 90. Now a square is 4 congruent angles and 4 congruent sides. So a square is a special rectangle. The definition for a rectangle is all congruent angles. And A, B, C, D. Which one did you go? Who got 6 right? What is the answer, Ryan? What? Very good. C. The diagonals are going to cut each other in half. So check it out. If you look at it, definitely on a square, I mean, it cuts the angles in half. That's a 45. That's a 45 if I tell you that's a square. And the diagonals, they meet right in the dead center. So this diagonal, that's congruent to that. And that is congruent to that. So rectangle, if you cut them, if you go diagonal, they're going to bisect each other. That means this is the median of this, and it is also the median of this. What do you know? Okay, let's look at 7. Which of the following figures always has congruent diagonals? Who got 7 right? What'd you put for 7? How do you not remember? What'd you put, CJ? Got it wrong? Rectangle. Okay, let me show you this right now. You guys have got to get on. So today's assignment, you're gonna get into Canvas, and I've got something for you to look at for these shapes: kites, parallelograms, rectangles, rhombus. Let's click on rectangles. If you click here, it's going to take you to a little applet. So this applet, you can kind of move these around, maybe. John, I guess I can. There we go. Now, for it to be a rectangle, all these angles got to be the same. So that's the same as that. Check. That's the same as that. Check. That's the same as that. So the angles are all the same. Now, if I go diagonal, so this blue one right here, if I take this diagonal and slide it out, anchor it down, and rotate it, boom. Those two diagonals are the exact same length. That's true of any rectangle. The diagonals are always going to be the exact same line. Okay, so we go number 8. Okay, 8 should have been a freebie. What's the relationship between angle 1 and angle 4? They're C, they're vertical. Very good. What about 4 and 5? That would be adjacent. Or you could put, are they complementary or supplementary? They're supplementary because they make 180. 180 makes supplementary. Okay, number 9. Who got number 9 right? That's right, Hallie. Shout out to Hallie. You're number 9 correct. Okay, this is a proof. We've never done this. It's a drag and drop. You've got 1, 2, 3, 4, 5, 6 options, and you got to drag and drop them in the right spot. So here's what they're doing. They're kind of manipulating and coming up with the formula for the circumference. Circumference of a circle equals pi times diameter. That is the formula for circumference. And they're suggesting that it's going to be equal to the same thing as circumference equals 2 times pi times r. Which is true because 2 radiuses is 1 diameter. So that's a true statement. So now here's how they're going to prove that. They're going to start with this. A circle has a radius r, a circumference c, and a diameter d. Hallie, which one did you drag and drop? Okay, that information is given. Check, used it. Now, circumference divided by diameter is equal to pi. So what did you drag and drop here? That is, they're defining pi. That's what pi is. Pi is circumference divided by diameter. So you're going to drag and drop this. That is the definition of pi. So far not bad. Okay, now 3 is where it gets funky. So now they're going to take this formula, pi equals circumference divided by diameter, and they're going to solve for c. They're going to times this by d times this by d, so they got c equals diameter times pi. Hallie? So here's what they did. They times this side by d, and they times this side by d. And d times d divide d kills out, so you just got c equals pi times d. So we are going to drag and drop this guy. The multiplicative property. So you can guess on these and probably do pretty good. Okay, now look what they did. So they're saying the circumference equals pi times diameter. Now they're saying diameter equals 2 radiuses. Zane! That is definition of a diameter. Okay, now this one's probably hard. Circumference equals 2r pi. No, what's commutative property? Yeah, the last one is commutative. Do you guys remember commutative? Commutative is this. 2 times 3 is the same thing as 3 times. You can change the order. So look what they did. The last one. The first one, it was c equals 2r pi. The last one was 2 pi r. So that's commutative. So this one's got to be, all they did was substitute. So look, this substitution, this is the idea. 4 equals 3 plus 7. So if I have like 5 plus 4 equals question mark, if I know that it's not 3 plus 7, it's 7 minus 3 is what I meant. So 4 equals, look, 7 minus 3. If that is true, anytime you come across a 4, you can substitute in its place a 7 minus 3. So because this is the same thing as 4, I've got a 5 plus 4. I'm going to substitute in place of that 4 something that is equal to 4, which is 7 minus 3. So that's swapping out. That's substituting. And they substituted for circumference. This circumference is pi times diameter, but this circumference, or diameter, is 2 radiuses. So they changed the diameter for 2 radiuses. They swapped them out. Okay, number 10. This one, you got to draw your own map. Downtown, this one for sure is going to be on the stage. City Hall is located in quadrant 2. Left 3, up 2. That is City Hall. The library is located in quadrant 4. Over 5, down 8. That is the library. What is the shortest distance between? So we just did this with circles. This is triangle. If you're going to connect those 2 dots, the shortest distance is a straight line. You've got to Pythagorean theorem. A squared plus B squared is C squared. You've got to make a 90. You got to make a triangle. So you either go down and over, or you can go across and down. Doesn't matter which triangle you looked at. But you have got to find the dimensions of this triangle. So this, I'm going to take this dot to the x-axis. This dot was at negative 3, 2. So that is negative 3. This dot I'm going to take to the x-axis. This dot is at 5, negative 8. So it matches up with 5. So what's the distance between a 5 and a negative 3? How many units is that? If I go negative 3 and I walk all the way over to 5, you should walk 8 units. Very good. Who was that? Will Sanford. Got it right. He's the man. If you see me in the hall, give him a hug. Next one. Let's take him to the y-axis. If I take this to the y-axis, that is up high at level 2. This one is down at level negative 8. So what's the distance between a 2 and a negative 8? Alright, 10. So now check it out. Now we're getting places. Who said that? Will Sanford again. Excellent remark. 10 tall, 8. So you've got to find the hypotenuse. So we got to go 10 squared plus 8 squared equals C squared. 10 is going to change to 100. 8 squared is going to be a 64. Dude, I think we got a problem. 164 equals C squared. If you square root, oh, it's got you rounding it? No, round. Okay, round it to the nearest whole number. Because square root, I know this. 169 is a perfect square. That's 13. 164 is not perfect, but it's going to probably go B. You guys put B? Okay, number 11. This is the problem no one in the entire school got. Curtis, easy. You got this. Alright, Curtis. Check this out. This dot right here. Give me the specs. This dot is over 2 up 4. This dot is over 3 up 6. This dot is over 6 up 4. This dot is over 9 up 6. Okay, you got to know where the dots are. Now, the scale factor, that's going to change dilation. So dilation is going to kind of change the steepness, change the length. They're going to center the dilation at 0, 0, so that's kind of the origin. And if they dilate it, this is what you begin with. This is the pre-image. And this is the post-image. So this is A apostrophe B apostrophe. We call it A prime and B prime. So now the scale factor. Scale factor is just a ratio. It's just a fraction. It is exactly like, let's do 12 first, because 12 is using scale factor. 12, you've got this triangle right here. This is angle, angle. So check out this little triangle. This little triangle, whoa, 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 whoa. You've got a little triangle right here. That is a 90. This angle right here is the same angle as in the big triangle. That's the same angle. So if 90 is the same as 90, this angle is the same as this angle. Maverick, by default, this angle has to be the same as this one. So that means these two triangles are the exact same shape. They're just different size. So they use the scale factor. So let's find out what that scale factor is. So you're going to compare, you start setting up these ratios, and that is the scale factor. I'm going to compare 10 to what? 10 compares to 60. So that scale factor, your scale factor is 1/6. Or if you go 60 to 10, then it's 6/1. So that's your scale factor. So now check it out. You're comparing 10, the bottom of the little, to the bottom of the big, which is 60. That means you're going to compare the side of the little, 12.5, to the side of the big, which is x. And now because you've got a proportion, just cross multiply. So you got 10x equals, cross this way, 60 times 12.5, whatever that is. What's 60 times 12.5? 75? No. 60. 750. So if I divide by 10, who got the height is 75. Who got it? Raise your hand. I'd like to recognize Kel. Oh, because I didn't use 1, 6, I used 10 and 60. So if you be 6, you're right, yeah. Okay, so 75. So look, that is scale factor. So now check this out. Here is your scale factor. I'm going to compare this dot, this x, to this x. 3 is going to compare to 2. This y to this y. 6 to 4. This to this. 9 to 6. This to this. 6 to 4. What do you notice about all these? They are all, that's cleaned up 3 halves. That's cleaned up 3 halves. That cleans up to 3 halves. That cleans up to 3 halves. So I think I found my scale factor. Now, here's what we're going to do. We're going to use the scale factor. Let's do a little math. Now, three. If you take, I'm going to compare, I'll bet you, if I do it again, the new line's going to be up here somewhere. So if we go again, let's use that same scale factor. So we're compared, this was the first one. This was my first line right here. And this was my second. So what's my new x gonna be? What's this new x gonna be and the new y? If we go 3, so I want it to have the same thing. I want it to still have 3 halves. So I did the old one on top and the first one on bottom, so 3 halves. So this is going to be the new one. So I've got the old one on bottom, so this is the old one, so I'm going to put it on bottom. So I'm going to put 3 on bottom, but I want it to have the same as 3 halves. So what do I got to put on top? It's got to be 3 halves. If I put 9 divided by 3 is 3 ones. So this is x. So cross multiply. What's 3 times 3? That's 9. Cross this way. What's 2 times x? So I want this to be 4.5. Okay, now let's do it again to see if it makes sense. Now for my y, so look how I set this up. This is how I set up the original. I put the new line on top and the old on bottom. So this one is going to be my old. So 6 is the y, so 6 is going to go on bottom. My new one is going to come up here somewhere. I don't know what it is, but I want it to have new to old 3 to 2. So let's cross this way. What's 6 times 3? What's 18 divided by 2? That is a 9. There's your... Everybody go over 4.5, go up 9, and that is your dot right here. Okay, now this is A double prime. So you've got to label it A prime prime. Now let's do the same math. We want it to have the same scale factor, 3/2. So let's take this old dot. This dot right here is 9, 6. So that's the old dot. And I want it to be the same as 3/2. So I want 27 divided by 2. What's 27 divided by 2? 13.5. 13.5, and then let's do one more. We already got this. It should be a 9. So now go over 13.5 and go up 9. And that dot is B double prime, and then you gotta connect them. So there we go. What if we did it again? So the big idea is compare the points, and you could have compared the other way. I could have compared 2 to 3, and 4 to 6, and 6 to 9, and 4 to 6. If we would have done this way, we would have got 2/3. But then you got to set these up different. Okay, that concludes the video.